In this Oracle Mobile Cloud Service episode, we're going to explore the Storage API from an iOS developer's perspective using the MCS Mobile Client SDK. Thanks for joining me today. I'm Chris Muir from the Oracle Mobile Platform team. In previous episodes, you gained an in-depth knowledge about the MCS Storage Platform API, including how to create collections and manipulate objects and interact with them overall through a REST web service set of calls. In this episode, you will discover how productive you can be when using the MCS Client SDK to interact with the MCS Storage API via iOS. So continuing on from our previous episode, we'll run with our fictitious Spell Wars application to help children learn how to spell. Now, Spell Wars makes use of the MCS Storage API to store user preferences, such as an avatar picture, in an isolated MCS collection, as well as a shared MCS collection, a scoreboard essentially, tracking this week's spelling champions. In specifically covering the iOS APIs for the Storage API via the MCS Client SDK, it's hard to say, here are the scenarios we're going to cover in this particular episode. First, under the identity of Little Joe, the mobile user from our previous episode, the app will determine if the isolated user preferences MCS collection for that user already exists and if Little Joe has the appropriate privileges to work on that collection. Then, for the same user, the application will determine if an avatar picture has already been uploaded. Assuming an avatar picture already exists, we'll then delete it and upload another one. And then finally, from the shared MCS scoreboard collection, we will show how to download the last 5 scores in order to display them in the application. In getting started and showing you how to achieve this in Objective-C and Xcode, we'll wire up a very basic application with a single button to call our code. Now let's admit it, in a real application you wouldn't do this, but this is a 10-minute video, and so for our demonstration purposes, it will suit our needs today. So very quickly, in a vanilla app's main storyboard, I'll add a button and wire it to the view controller calling a function storage API call. Having wired up a button and an action method to actually invoke some code, we've got a place to add our actual logic. Now, before we can call the Storage API code, it's necessary to authenticate the user against the MCS backend. Now, we have explained this in detail in previous episodes, but the basic code to do authentication is as follows. First, we import the following classes. Then in our code, we access the default mobile backend and seek access to the OMC authorization class. From there, the authenticate method does the hard work to authenticate the user. And for demo purposes, once again, we're completely cheating here and hard-coding the username and password. A real app, of course, would have a login screen to retrieve these credentials. Having got the authorization code out of the way, our real first task with the Storage API is to check if the user preferences isolated MCS collection exists for the user Little Joe. First of all, for the Storage APIs, we need to import the following additional headers. These enable us to manipulate the backends and storage collections. From here, we simply obtain a handle to the backend, and we'll use the default mobile backend specified in the omc.plist file. And from this, create an instance of OMC storage. The last line of code shows a call to the getCollection method in order to gain access to the collection for the user currently authenticated on the mobile backend. If we retrieve the collection by name, as we see in this example where we've specified user preferences, we need to remember that the name is case sensitive and must be specified exactly as it is displayed and set in the MCS user interface. Alternatively, it is also possible to retrieve a collection for another user by calling getCollection for user ID. This allows the current user to retrieve an isolated collection for another user, assuming that user has the read all or read write all privileges on the collection. Both methods will return an object instance of the collection if it exists, and nil if the collection does not exist or the user doesn't have the privileges required to access it. Now, for demo purposes, we'll return to the original getCollection call for retrieving the collection for the current user, Little Joe. At this point, our application has confirmed that the collection exists. Now, the next step is to check if Little Joe has already uploaded an avatar picture to the user preferences collection. This is achieved by calling the contains method of the MCS Storage collection class, as we can see here. Now, if contain returns true, we know that an object called avatar exists in the collection. From here, if we wanted to, we could then write code in order to fetch the object from the server. Now, this is a two-step process. First, we call get on the collection to obtain a pointer to the specific object we want to retrieve. Then second, we get the actual data from the server. To do this, we can use either the get payload data or get payload stream methods. Fetching the object from the server is not the only thing we can do with the pointer to the object. We can also delete the object. So this is done using the following code. Further, we can also delete an entry from the collection without a pointer to the specific object by using the delete with key method on the collection. As we can see, manipulating the objects in a collection is relatively simple when we use the MCS client SDK. Alternatively, if we were having to write code to make raw REST calls, this would be significantly more lines of code. Now from here, our next goal is to upload a new avatar picture for the Little Joe user. Now admittedly, we could have in fact just done a straight put overriding the original avatar picture with the new picture, but we wanted to show you how to remove the previous avatar picture and then upload a brand new one. So this is why we're going through these, I guess, very granular steps. Anyway, let's have a look at how we can upload a new picture. And again, this is just done in a few lines of code. The first thing we must do in order to do this is create a storage object for Little Joe's avatar picture. We can create this object from an image already loaded in memory or from a stream. And in the latter case, the stream can point to a file stored on the device itself or some remote URL. Now in this code snippet here, it shows how to create the storage object from memory. And what we've done here is we've created a PNG image from a base64 encoded string, which is then used to build an instance of NS data. We then create the storage object by specifying the file name as the first parameter value for the init payload method. We also need to remember to set the content type to the correct MIME type, in this case image PNG. We then use the put method of the MCS storage object to send the image to MCS, and the object ID will be set to that of the file ID. Alternatively, if we want MCS to generate an object ID for us, we can use the post method. Separately to this, sending an image stored on the local file system to MCS through a stream is nearly as easy. Suppose we want to upload a file named oracle.gif located in the application's documents folder. To create the stream, we simply obtain a path to the file as shown here. Then we create and open the stream. Next we call init payload with stream and content type to create the storage object, and then use the collection's put method to send it to MCS. Finally, the last thing left to do is to close the stream. The last scenario we want to cover in this particular episode is how to retrieve the 5 most recent scorecards from the shared MCS scorecard collection. To get started, we need once again to acquire a pointer on the collection. Then we simply call the getWithLimit method on the collection to retrieve a specific subset of the objects. Now the first parameter here is an offset, while the second specifies the maximum number of records to return. If the call to getWithLimit succeeds, the objects are returned as an instance of NS mutable array. Accessing a specific object in the array and reading its properties is easy, as you can see here. In this example here, we're accessing the object's content type. With the inclusion of these parameters, the getWithLimits method makes it easy to implement pagination. For example, if I need to retrieve the next 5 objects, I would use the following code. Now, at this point, maybe you're curious about what the getAllObjects parameter does for the getWithLimits method. Now, for shared collections, it is ignored, so it's not very useful. But if the collection is isolated, however, the call will return only the objects for the user's own isolated space, if getAllObjects is set to no. Alternatively, if it's set to yes, the call will return records for all users. Granted, the authenticated user is a member of a role with the read-all or read-write-all privileges on the collection. There you go, you now have an idea how easy it is to work the Storage API in iOS using the MCS Mobile Client SDK. Thanks for joining me in this episode today. I hope it's been useful to you, and I hope to catch you in another episode very soon.